This is section 3.6, Negations of Conditional Statements and De Morgan's Laws. We dealt with De Morgan's Laws back in chapter 2. They are coming back. They are essentially the same rules. It's just the way that we talk about what we mean by the word not changed. So our symbols are different, but the same idea exactly is what we've been doing. Now, we have talked about negating in English. We've talked about negating quantified statements, but we have not talked about how to negate a conditional or even an or an and, not completely. Okay, here's the first part. The negation of P, if P then Q, is P and not Q. So the negation of a conditional, you keep your first exactly the same, and then you're going to negate the second part. Okay, so if we were just told, if the directions said to negate this, we would write not the conditional, and that is equivalent to, and then we get the second part right there. Now, in the last section, we talked about contrapositive, converse, inverse, and all of these. And I made a point of indicating that these are not negations because they did not have exactly opposite truth values in every case. But we now have a negation here. So for here are our properties of the conditional. Contrapositive is always true, is always the same as the original. And to find the contrapositive, you flip the conditional and you negate each one. So this is a legal move. Now the converse and the inverse, you can see that there's a line marking through these. These are not equivalent to our original one. But to find the converse, you simply switch the front and the back, but you do not negate it. And then inverse, you keep them in the same order, but you negate each one. Okay, and then here's the negation rule we just talked about. So let's look at an example problem or two. We are asked to write the negation of each of these. Now here it's in symbols already, which makes it a little bit easy for us. What I have, our rule says, to find the negation of it, so I'm just going to put a not P, if not P, then R. So I'm negating this whole thing right here. Now this says to negate it, you write down the first one exactly the way it was. So this is equivalent to not P because that's what's in this position right here. And not the second part, so not R. So the negation of this conditional is not P and not R. Okay, let's do the same thing here. If the TV is playing, then I cannot concentrate. We need to figure out our P and our Q, and then we can go about negating them. So I'm just going to say, I'm going to do it this way. The TV is playing, I'll call P. And I cannot concentrate, I will call Q. And our original is if P, then Q. And we want to negate this, so if I put a not in front of it, we keep the first part the same, P, and the negation of Q, not Q. So if I'm going to write this out, the TV is playing, and the negation of Q, this says I cannot concentrate, so we just change it to can. The TV is playing and I can concentrate. All right, this one. If she says yes, he says no. Okay, let's say she says yes, and we'll call that our P. He says no. It's an understood, the word then is in there, it's just understood. He says no, I will call Q. And we are asked to negate this, which by our definition is P and not Q. So P, she says yes. And he, now this is a little bit tricky. We, on a paper test, if you said he says yes, I would take it as the negation of this. But technically, you know, you can say things other than yes or no. You could say perhaps, maybe later, I'm not sure. You have a lot of options there. So the most correct way of doing this is to say that the negation of he says no would be he does not say no. Okay. It allows for him to say things, the other things, perhaps, maybe, we'll see, all that. But there we go.